Hello, so this is Stephen Huang on the Fundamental Theory of Calculus, Part 1. This is section 5.3 in the textbook. If f is continuous on a to b, then the function g defined by g of x equals the integral of f of t dt from a to x, where x is between b and a, is continuous on a to b and differentiable from a to b. But most importantly, g prime of x is equal to f of x. So I'll try to give you a visual of this. So we can have any graph here, and we can call that f of t, and it goes from a to b, where x is between a to b. So this right here is this, and the derivative of g of x is f of x. So I'll try to give you the basic solving process of this. So you have this g of x, and you want to find the derivative of this. And what we want to make sure is a, the constant, is always the lower bound, and x, or whatever function, is always the upper bound. And what it pretty much is g of x equals f, we can call this x, any function h of x, and the derivative of this x, call that h of x again, right, is f of x. It's this. And this can be asked in multiple ways. You can be asked to find g prime of x, or you can be given this notation right here, and it's asking the same thing. It's asking to find derivative of g of x. So now we'll begin to solve a couple problems. The first problem we have here is g of x is equal to the integral from 2 to x of root quantity 6 plus t to the 4th dt, and it's asking for us to find g prime of x. So what we can do is, it's rather simple. You just plug in the x to where the t's are, and we would find the derivative of x, but that's just 1, so it doesn't change this. On to the next problem. So this problem is a little more complex. It's going to have the use of a chain rule with this cosine x here. So it's the same thing as the previous problem, it just asked a little differently. The derivative of this function right here is cosine x to the 3rd power, and we use a chain rule here, minus sine of x, and that's the derivative of this integral right here. For our next problem, we have g of x equals integral of t cubed over t squared minus 4 from x to the 4th to negative 6, and we're being asked to find g prime of x. So as we can see here, negative 6 is the constant, but it's not on the bottom, so we have to flip this. When we're flipping, we put a negative on the outside. So what we have now is this right here. So when doing this, it's You keep the negative on the outside, but everything else is the same. You plug in x to the fourth for all the t's. X to the fourth is 4. And we take the derivative of x to the fourth, and that's 4x cubed. So this means that g prime of x is equal to negative 4x to the 15th over x to the 8th minus 4. So this would be our last problem, and what we have here is g of x is equal to the integral of cosine t times t squared dt from pi to 2x plus 4, and we're being asked this time to find g prime of 2. So we notice here that the constant is on the bottom, so we don't have to do any flipping. So we just begin. G prime of x is equal to cosine 2x squared plus 4 times 2x squared plus 4 squared, and then the derivative of this, which would be 4x. Now I want to find g prime of 2. So we plug this in, we get 12 here. Multiplied by 12 squared, and then 8. And using a calculator, we get that this is equal to 152 cosine of 12. Is this also about 972.120? Now for a few last reminders. So the constant has to be the lower bound to the integral. It has to be a constant. If it's not, then you would flip the integral and add a negative on the outside. And you also do not forget to take the derivative of the x, the upper bound to the function, and also multiply that in. And I hope that was helpful.